pre-cal student, you're probably familiar with this thing called the unit circle. And you're probably also familiar with how long it took you to memorize it, and then the challenges there are in trying to actually use it. Heck, I'm a pre-cal teacher and I am familiar with those challenges. So is there any easier alternative? As it turns out, yes there is, and that's the topic of today's video. Told you this, but the whole unit circle is built on the concept of just two special right triangles. In your geometry class, you probably learned about these special right triangles, but maybe you never understood just exactly how special and easy to use they can be. So it's built around the 45-45-90 and the 30-60-90. And if you can just memorize two triangles, I promise you, you can do any problem that you would have needed to do using the unit circle instead. But it'll be easier and require a lot less memorization on your part. So the 45-45-90 triangle, across from each 45-degree angle, is a size of 1. And then across from the 90-degree angle is a size of square root of 2. Now obviously these can be manipulated and you can multiply them all by something to make them bigger or smaller. But basically it's in the proportions 1 to 1 to square root of 2. And then for the 30-60-90 triangle, across from the 30-degree angle is 1, across from the 60-degree angle is the square root of 3, and across from the 90-degree angle is 2. And again, you can multiply these sides by whatever factor you want to make that triangle bigger or smaller, but those are the basic proportions. So now let's talk about how we can use these two special triangles in some problems that you would typically use the unit circle for. So let's say, for example, we wanted to know the tangent of 300 degrees. If you were to use your unit circle, first of all, you'd have to have that entire unit circle memorized. You'd have to know where 300 degrees was. You'd have to know the coordinate at 300 degrees. You'd have to know how to apply your sine, cosine, tangent, cosecant, secant, cotangent formulas to that coordinate. Then you'd have to put it together in a fraction, simplify your fraction, and then you'd have your answer. That's a lot of work, and for a lot of students, that just creates too many places where you could make a mistake. Using special right triangles, it's a lot easier, so let's take a look. Let's draw just a coordinate plane. If you want to put a circle around it, you can, but there's no need. Here's 0 degrees, 90 degrees, 180, 270, all the way back to 360. So 300 degrees would be somewhere around in this region. Right there, that would be 300 degrees. So let's see if we can create a special right triangle in this picture. Now I know that from here to here, the difference between 360 degrees to 300 degrees, I know that that's a 60-degree angle. And you always, when you figure out 60 degrees, you could have figured out 30 degrees here, but that would have had you stopping just a little too short of your 300-degree angle. You always want to think about it in reference to the x-axis. Just so you know, always think about it in reference to the x-axis. So here's my 60-degree angle, so let's make our little special right triangle from there. Just like that, so I've just dropped a triangle off of the x-axis. The right angle is always on the x-axis. 60 degrees, this has to be the 30 degrees. Let's label our special right triangle. I know that across from the 30-degree angle is 1. Across from the 60-degree angle is square root of 3. And across from the 90-degree angle is 2. Furthermore, I know that tangent, you can think SOHCAHTOA if you want, tangent is opposite over adjacent. So opposite from the 60-degree angle is square root of 3. Now I want to say that that's a negative square root of 3 because you're going down, so it's really negative square root of 3. And adjacent to the 60-degree angle is 1, and it's a positive 1 because you're going to the right. So if you simplify the negative square root of 3 over 1, you get negative square root of 3. So the tangent of 300 degrees is negative square root of 3. Now just to make sure that you really understand this, let's try a couple more problems. Let's try finding the cosecant for 150 degrees. So again, just draw an XY coordinate. Here's 0, 90, 180, 270. If you go all the way around, there's 360. 150 degrees would be past 90, but not quite to 180. It would be about right here. Now let's make our special right triangle. Remember, you always want to think about your angle in relationship to the x-axis. So let's think about how from 180 to 150 is a difference of 30 degrees. And then let's make a special right triangle. Remember, the right angle is always going to go on the x-axis. So this is clearly the 60-degree angle. And then let's label our special right triangle. Across from the 30 is 1. Across from the 60 is the square root of 3. Across from the 90 is 2. Cosecant is the reciprocal of sine. So sine is opposite over hypotenuse, which means that cosecant is hypotenuse over opposite. So from this angle here, the hypotenuse is the 2, and the opposite side is the 1. So 2 divided by 1 makes 2. So the cosecant of 150 degrees is 2. Last one. Let's go ahead and find the cosine for 225 degrees. Just like always, draw out your XY plane. And 0, 90, 180, 270. If you go all the way around, you get back to 360. 225 degrees. You'd have to go past 90, past 180, not quite to 270, so it would be right there. And then that would be about 225 degrees right there. So then you can draw in your special right triangle. Ooh, let's do red this time. You'll see why in a second. Let's draw in our special right triangle. Remember, you're always going to connect it up to the x-axis. The right angle is always going to be on the x-axis. Let's think about what this angle would be here. From 225 degrees to 180 degrees, that's a difference of 45 degrees. That's why I did red, because earlier in the video, my special right 45-degree triangle was a red triangle, so I was like, oh, let's do red. Okay, so anyway, this is 45, this is 90, this would be another 45 down here. And let's label that. Across from 45 degrees is 1. Across from 45 degrees is 1. Across from 90 degrees is square root of 2. Now cosine, oh, and I should mention, this is a -1 because you're on the left, and this is a -1 because you're going down. So cosine is adjacent over hypotenuse. To this 45-degree angle here, the adjacent is -1. And the hypotenuses are always positive, by the way. The hypotenuse is square root of 2. Now, mathematically speaking, it is just so tacky to leave a square root in the denominator, so we would just rationalize that denominator real fast. Just multiply it with itself. So we get -1 square root 2 over, and whenever you multiply a radical with itself, it just undoes the radical. It just leaves you with regular 2. So there's your answer. There's the cosine for 225 degrees. Thanks for watching today. If you need more help, just go to my website and contact me from there. Thanks.